Hi everyone, welcome to the IoT Audit Introductory Module 3. Here we're going to talk about the IoT Strategic Map, your task plan, and your business optimization. Let's get started. In Module 1 we discussed the important reasons for the IoT audit and the various outputs that will be used to construct a successful IoT deployment business plan. In Module 2 we did a deeper dive on your IoT target outcome baseline analysis and expectations interviews. If you did not watch these modules, please go back because this one is in context with these other two. So please go back to 1 if you haven't seen it, watch 1 and 2, and then join me now in Module 3. Here we're going to detail the strategy map and metrics, your tasks implementation plan, and your business optimization actions. So recall the IoT audit solution framework. Like I said, we went through the target outcome baseline and expectations in Module 2. Here we're going to talk about the strategy and metrics. We're going to talk about your strategy map, your staffing, funds, and time expectations identification. Talk a little bit about, again, leading KPIs and lagging KPIs. We're going to then launch into your tasks implementation plan, and lastly, your business optimization. You'll remember this IoT audit project process detail chart from the last module. Here you can see we're going to focus on the back half of the process, where we're going to build your IoT strategy map predicated on what you did in your baseline and expectations phase. We're then going to move to your IoT project plan and actually identify the different pieces that need to come together for a successful IoT deployment. And then we're going to look at how to optimize your business predicated on the information coming from your IoT deployment. So in the context of the IoT audit philosophy, in the previous module we really got our arms around our purpose. Now we're going to basically look at our process, which is our strategy map, and our tasks, which is essentially the products. So again, we're going to look now at the how we're going to do an IoT deployment, and then the what, all the things that need to be done to realize a successful implementation. And finally, looking at it this way, looking at this particular process flow, we're going to focus on the last 3 legs here: strategy map, tasks, and performance optimization. So if we expand our strategy and success metrics bubble from the previous flowchart, we can see here we're going to look at first creating the strategy map for our baseline and expectation process results. Then we're going to document the key performance indicators, both the leading and lagging metrics. We're going to calculate target return on investment metrics. We're going to document our revenue growth target metrics if that's part of our target outcome. We're going to identify potential market expansion targets. And lastly, identify the business optimization metrics. So this is a very important slide. Here we're creating a strategy map from our baseline and expectations. And I'm using an example target outcome. It's the box in red here. So we're going to build a strategy map for: we will improve our factory machinery uptime from 80% to 95% in 12 months. It's a very concrete key performance indicator that we're looking to improve. Now on the left-hand side, we're looking at the who, in other words, all the people that we need to get expectations from and understand, motivations and emotions of various organizations and the stakeholders involved, what the required skill sets are going to be for our IoT deployment, the monetary resources required, timeline expectations, and then lastly, all of the data sources, how they're collected, and the analysis. And then over on the right, we have the KPI analysis. I'm going to show you how we break that down using the why, how, what process in the next slide. And that's going to drive our IoT implementation by creating linkages from specific parts of this flow diagram. So again, the process steps are: do a why, how, what on all the baseline areas on the left side, use the IoT reference model to begin the IoT implementation planning, and then we're going to move all the strategy map analysis over to our IoT task project plan. To create the strategy map, we're going to follow the following steps here. Again, we're going to go down the left-hand side of this particular strategy map diagram. We're going to collect and document the expectations from all involved parties. And as we talked in the previous module, Understanding everyone's expectations is critical to a successful IoT deployment. We're going to understand the synergies and the conflict between those expectations. We're going to identify all our staffing resource requirements, especially the skills required. Sometimes IoT brings different skill requirements, especially in data analysis, to your company, along with the number of resources we're going to require. We're going to find out where we're getting the money for the project and the amounts of money available to us. We're going to understand timeline from the perspective of the project team versus management, which are usually not the same. One is usually a bit more pessimistic and the other is much more optimistic. We're going to develop the sources and systems and teams for the data collection and analysis, a very important step because we're going to look at existing infrastructure data and some operational intelligence you'll have that will marry into your IoT implementation data analysis. We're going to then perform the why, how, what analysis on the key performance indicators to get the sensors that we're going to need to collect that infrastructure data. And then we're going to map the sensor and our data collection analysis over to the IoT implementation strategy. This is a very important slide because what we're doing here is we're exploding out the KPI analysis using the why, how, what methodology to determine the root cause of the impediments to reaching our target outcome and where to extract the infrastructure data using the appropriate sensors. So I know you can't see this on this slide. All these materials are in the IoT audit course. But what I'm doing, moving from left to right, is actually determining which sensors and what modalities you need. For instance, temperature sensors, pressure sensors, flow sensors. You're going to need to understand and collect the infrastructure data required to create the operational intelligence that in turn is going to help you solve your target outcome. Okay, so how's this slide for an eye chart? I realize you can't really read any of the text in the diagram, but let's look at it from 50,000 feet here. You can see in the middle in that red box, that's our target outcome, where we're looking to improve our machine uptime significantly. Over on the left, those are the same boxes that we did for our baselining of all those items. Up in the upper right-hand corner, that's that KPI analysis where we're using the why, how, what methodology to get down to the actual sensors that we need for the infrastructure data. You can see that red arrow there feeds into the IoT implementation flow. And we're going to look at that specific part, which is the lower right-hand corner of that flow chart, in the next slide. Over on the left, we have the data sources, collection methods, and analysis tools that we want. We backtracked that data, and that's going to flow into the operational intelligence area of our IoT implementation. So we have that information flowing in, we have the sensors that we want coming in, and that information is critical then as we look to build our IoT implementation plan. All right, now the last slide even made me dizzy, and I created it. So let's take a simple review again because the points are really important here. We're creating our strategy map. On the left-hand side, we collected our baseline data. And the really important data that comes across is your current data that you're going to use along with your new IoT data, all of people's expectations, the skills, the money resources, and time expectations feed into the IoT implementation plan. And then on top, we did our KPI analysis breakdown using the why, how, what analysis to give us the sensors we need to unlock hidden infrastructure data that is then going to flow into our model as well. So now that we have that data, we can look at the IoT implementation planning. Here we have the IoT implementation diagram. This is what was on the previous slide in the lower right-hand corner. Now, this is also flipped over from the other one because we were bringing the KPI analysis sensor selection into the top of this diagram, and from the left we were bringing the data analysis into the business intelligence section here. But this is represented in the reference model fashion we've talked about in previous modules. You can see at the bottom the sensors, which sensor devices we're going to use, and its connectivity to the gateways that is going to take the data off the enterprise site to your repository, whether it's in the cloud or in another part of your enterprise, via a network. There's going to be security and data abstraction tools that are interfaced then into a cloud scenario, where then your application software, which is primarily business intelligence applications, are going to do the data analysis you need then to optimize your business performance. Again, in the IoT audit course, we go through all this in great detail. Here's our friend again, the IoT reference model. You can see how the layers here map to the implementation plan we had on the previous slide. So we go through this layer by layer to make sure that all the components of the plan fit together. Now that we have our strategic plan put together, it's time to take a look at the IoT project plan and identify the tasks that make up that plan. Now, the word task was chosen very specifically. A task has several attributes that a step, which just identifies a particular action to be taken, does not. A task has the following: a time duration, an accountable person responsible for the task achievement, the steps to complete that task, and a results tracking scorecard. Tasks is actually an acronym. In this case, T stands for time. A task has a specific start date and duration assigned to it, and when the desired output of this task is to be realized. A stands for accountability. A single person is accountable to get this task done. If you're going to have a successful IoT deployment, you need to have single points of accountability for every task. S stands for steps. These are the specific actions that must be taken to achieve the task. It is very useful to break these down, especially if there's a lot of steps in a task output. You might want to break down this larger task into smaller tasks. Lastly, K stands for keep score. Create and use your IoT project schedule that identifies all the steps to be done and by whom, by when, and then create and use the KPI scorecard. Lastly, measure team engagement by survey, either in person or by third party, because an engaged team is a productive team. Remember, they need to believe in your project. So as we look at the breakout now of the task implementation, you can see the process steps, again, map to the architecture of the reference model. First, you're going to match the sensors to the business infrastructure to generate the required data. You're going to design the sensor connectivity to the gateway. Most likely might be wireless, but it could be wired. Then the gateway connectivity to the cloud. Again, that could be broadband through your enterprise network, or it could be wireless connectivity using cellular networks to your cloud service. Number 3 is identify and deploy the applications, platforms, and business intelligence software either in the cloud or in your enterprise. Then you're going to implement the appropriate level of security at each level and overall end-to-end. It's very important, obviously, to have a secure system. Then, staff and manage the IoT project within your timeline and budget. Measure and ensure the financial objectives, the time objectives, and the functionality of your network requirements are all realized. And lastly, create tests to optimize your business performance. Again, the whole purpose of doing an IoT implementation is to improve and optimize your business performance. Now, this industrial internet data cycle diagram shows if you had an industrial IoT, how you might collect and process the data. So up at 12 o'clock there, we've got industrial machines with sensors. We're then uploading and storing the sensor data to industrial data systems, many of the legacy systems known as SCADA style systems. That data is going to be sent to sense and control algorithms, where you may have a suite of software for cloud-based analytics. Now, once the data is analyzed, it's very important to have the data visualized so that you can create business intelligence from the data and make it useful for people to take action. And then that data is distributed up there about 10 o'clock. We've got physical and human networks, and the intelligence then flows to machines and business processes so you can make adjustments to optimize the performance of the network, and then the cycle continues. So now looking at our sensor attributes as part of our IoT implementation plan, we're sort of starting at that level 1 in the reference model. There's a number of different attributes listed on the slide. So you determine the sensor attributes required to create your infrastructure data. And areas you're going to look at are the safety of the sensor, the security, the actual sensor modality, the the volume of data created by the sensor, the data rates required for proper operation, how it's actually deployed and maybe potentially attached to the equipment, how it's configured, and whether or not you might use a smart overlay. So you see the process steps on the right here. Determine the sensor attributes. There'll be different issues to consider for each sensor. The logistics of the sensors that require attachment to machinery or to be inserted into flow need to be identified and engineered. And then lastly, the legacy system may need to be undisturbed. So you may have to use a smart overlay to add these new IoT sensors in, and it's essentially a separate network from the existing infrastructure on your machinery today. This slide lists many of the sensor type modalities that you might use in an IoT deployment. It's not an exhaustive list, but you can see here it's pretty significant in terms of the different kinds of sensors. You may want to stop the presentation here and take a look at these and review which of these sensors are going to make sense in your IoT deployment. Next, we want to take a look at the network and data infrastructure. What are your data transport mechanisms going to be? What type of cloud storage are you going to use? Where and how will your data be deployed? Are you going to implement action and alerting mechanisms, potentially even visual alerts in your IoT network? And lastly, you have to take a look at the integration with existing apps and software. So one of the first things you need to take a look at are your sensor to gateway connectivity. Is that going to be wired or wireless? You're going to identify the sensor multiplexing requirements of the gateway. Remember, you have a great deal of connectivity coming in here of different types, and it might even be mixed, wired and wireless, so your gateway has to accommodate for that. You may also have some edge computing going on or some data sorting or data filtering going on in your gateway, so you need to understand the requirements there. And then the gateway to the cloud or your enterprise, what's the transport for that? Is it going to be wired using some sort of broadband network, or is it going to be wireless, potentially using a mobile or cellular network? Then you need to architect your data deployment. Where's the collection, storage, and analysis going to be done? Then, as operational intelligence is created out of that data, are you going to utilize these alarms or alerts? And then lastly, IT must be involved to integrate your IoT data deployment with all the existing software applications and data stores that need to interface to your IoT deployment to create the data you need for business optimization. This slide speaks to the data science analysis and business intelligence you're going to use. You can see here the data science techniques are listed. Now this is an area that isn't talked a great deal about in the Internet of Things. Everybody seems to be so focused on the sensors and the connectivity in the cloud, is that this is where the magic happens. This is where you're going to analyze the data and be able to get yourself the operational intelligence you need to affect your target outcome. So the first thing you do is identify the types of IoT data to be collected. Then you're going to use a structured framework, such as the CRISP process, to be able to have a structured analysis of how you're going to use the data. And again, this is often an iterative process. You're going to try some things, find it works or doesn't work, and then move on. Because as it looks like an engineering process, it's really more of an R&D style process. So you need to keep this in mind when you're scheduling your data analysis tasks in your IoT implementation plan. And again, here you can see some of the key data analysis techniques: classification, regression, similarity matching, clustering, co-occurrence grouping, profiling, link prediction, and causal modeling. Your IoT deployment and your operational intelligence may use one or many of these data sciences techniques. So it's an area you're going to have to become very familiar with and invest in to have a successful IoT outcome. You can see here now that we're tied back into a slide we looked at in Module 2. What is the various levels of sophistication you're going to deploy in your IoT implementation for operational intelligence? It can range from reporting all the way up through prescriptive. This is the graphical way to look at that business intelligence progression model. We saw it in Module 2, and again, I really like this slide. We do a deep dive in the IoT Audit course around this because it really is the fundamental model that we're going to use to determine which types of data analysis are right for your IoT deployment. Please spend some more time looking at this chart. Maybe stop the video, absorb it, and move on. As part of your IoT implementation planning, you're going to need to look at your engineering and support resources in the area of hardware design, software design, installation, data transport, and overall maintenance of your IoT deployment, both the hardware, connectivity, cloud, and software. So you're going to need to identify the engineering resources for all of those areas. Then you're also going to have to understand how are the IoT sensors, network, cloud, software to be installed and tested end-to-end. There are a lot of vendors who only provide a piece of the solution. Very few people provide the end-to-end solution unless you're going to some very, very high-end vendors. So you may have some DIY, do-it-yourself, to be able to put some of these pieces together. Do you have those skill sets? And lastly, once it's all up and running, how are the IoT installations and data analysis going to be supported and maintained over time? Here we expand on the IoT required areas of expertise. We talked about it a little bit on the last slide, but you can see here that are you going to make or buy your sensors? And do you have the capabilities to actually do sensor development? You may have a unique situation where that's appropriate. Do you have embedded software skills for the sensors and or the gateways if you're going to roll your own? Do you understand wireless protocols both on the enterprise and connecting to the network? Network security is a key one, and security skills are in very high demand. Do you have those in the enterprise? Are you going to need to do some work with consultants on that? Do you have middleware skills, platform as a service analytics? Are you going to outsource that, or do you have that capability in your shop? And lastly, all the cloud storage management and all the reporting functions, along with all the software application installation and maintenance, is important as well. So these are all things to consider in your skills assessment and planning. This is a diagrammatic way to look at the skills question in the context of an industrial IoT software stack. And you can see again it maps to our reference model. Down at the bottom you've got all of your sensors, and here we are going to use potentially an M2M network to connect those to the cloud. And then as that information comes up from the network, you've got your data storage, data transformation, analytics, and the data management and application and analytics layer that oftentimes has a real-time access and analysis component as well. Do you have skills in-house to be able to deal with all of these areas? And across the top, these applications have specific requirements and specific algorithms and implementations. You can read the whole list here, but you may leverage one or quite a few of these in your IoT implementation, and you have to ask your team, do we have the skills to be able to pull this off, or do we need to get assistance to do it? Of course, as part of your IoT implementation plan, you need to consider all the financial implications of your project. Of course, you have to forecast and track the IoT project expense. You also need to forecast the hardware, network, cloud, and software maintenance costs. You need to consider what the replacement life of different parts of your IoT implementation will be, whether it's the sensors and they might have batteries that need changing, what the lifetime of your gateways and other components in the system is, and what those replacement costs will be. And you also have to forecast and track the software support costs, upgrade charges, and of course you may have software maintenance agreements you need to enter into. So again, you need to have all your upfront costs and all your recurring costs budgeted before you really pull the trigger on your IoT implementation. Here I wanted to take a minute and talk about what's called a PreMortem exercise for your project plan. Many people are aware of postmortems, where you analyze what went wrong after your project failed, or in some cases even worse, died. Instead, this tool we used with great success is the PreMortem technique. You analyze what can go wrong at the beginning of your IoT project. So this is a fantastic risk assessment tool. It empowers the people on your team who might hold back on their opinions and concerns normally, because this process values creativity and originality. You're imagining the future. And it also avoids groupthink, because the exercise of doing a pre-mortem is to think differently from everyone else. So dissenting opinions are encouraged, and when we do this, we also reward people for the kind of the craziest ideas that oftentimes actually are a possibility and it might impair your project later on. So it identifies future problems so you can see them coming. It's kind of an early I told you so that can happen now before the fact versus after the fact. Now in the IoT Audit course manual, we have a pre-mortem worksheet to help you through this process. And what it kind of gives you here is the opportunity around your target outcome to have both the disaster scenarios and the delight scenarios. Here's some additional information on the pre-mortem. It really does have significant upside. The project pre-mortem idea was discussed by Gary Klein in an article in the Harvard Business Review back in September of 2007. And it talks about how projects do fail at a spectacular rate. And the reason is many people are reluctant to speak up about their reservations during the all-important planning phase. By making it safe for dissenters who are knowledgeable about the undertaking and worried about its weaknesses to speak up, you can improve a project's chances of success. So this work was then predicated on some of the work done by Deborah Mitchell in 1989 at the Wharton School, and Jay Russo Cornell and Nancy Pennington, University of Colorado, as some of the fundamental background research around pre-mortem. In their surveys, they found that it increased the ability to correctly identify reasons for future outcomes by 30%. So you can see it has significant opportunity to improve the success of your IoT project if you do this kind of process. Another quote here about CEOs have attributed 21% of the reasons for success of a strategic initiative like IoT implementation to anticipating the obstacles. So you've done all your planning now. You did your baselining, you did your expectations, you did your strategy map, you created your IoT implementation plan. And now it's time for the payoff. So now you're finally here at business performance optimization. Once you get your IoT deployments in place, you're going to drive changes required to achieve the target outcome you've identified. Now these optimizations can take place in many corporate functional areas. One of the cool things about this, of course, is that you may be able to create new business models and introduce those to leverage the IoT data in profitable ways. And this can happen more than the original target outcome. Once this is in place, you'll probably be able to leverage the data in many new ways. And you can also, of course, use your operational intelligence data to prove compliance with regulations. So we talk a great deal in the IoT Audit course about taking final action around your IoT implementation, because this is really what it's all about. It's why you're spending the money and putting everything in place, is to optimize your business. Well, we've now reached the end of this module, and it's the end of the 3 introductory modules. I hope you've really gotten a lot of information around how to plan your IoT implementation. We covered many areas in the framework, from your target outcome, baseline, expectation, strategy map, and tasks. The acronym is BEST, and we'll talk a lot about that in the IoT Audit course. But you should be able to actually get started with the information that we provided you, and it'll definitely improve your planning process. But if you want to accelerate your progress, the IoT Audit course I spoke about quite a bit in these introductory videos provides a great deal of information. We have the detailed presentations. We break everything down into quite a few more modules. All of these modules have videos that are on a special website, all the flow diagrams that you saw, and I'll actually teach you how to do those flow diagrams and the tools that we use to generate those diagrams, along with very detailed IoT Audit worksheets for everything we explained. If you work through the IoT Audit process, you'll be able to create a robust business case for your IoT implementation that will really stand both peer and management scrutiny. Now, market analysis reports that just provide static market information around IoT cost upwards of $5,000. And consultants will often charge over $50,000 for an IoT planning consultation. But the IoT Audit course costs only $995. And viewers of the video, since you've gone through these 3 introductory videos, can order this for only $6.95. And the reason we do that is because we really want to see you move forward with your IoT implementation, and we believe that we can help you succeed. So please indicate your interest in the IoT Audit course in the form, and let's get going. I look forward, and the team looks forward to working with you soon. Thanks.